Okay, Mr. Holcomb here again. We're going to be doing another episode of Math Behind the Module. This is lesson 17, the unit rate as the scale effect. Okay, so here we go. Class 1. Example 1, Jake's icon. Jake created a simple game on his computer and shared it with his friends to play. They were instantly hooked, and the popularity of his game spread so quickly that he wanted to create a distinctive icon so players would easily identify his game. He drew a simple sketch. From the sketch, he created stickers to promote his game, but Jake wasn't quite sure if the stickers were proportional to his original sketch. Keyword here, proportional. If I'm going to increase the size of one side, I have to increase the size of all sides the same rate. So the original sketch is on the left, and the sticker, which is the scale model, is going to be the sticker. So I'm going to put original here, original, and scale. Alright, label that X to remind myself what's going on here, X and Y, and I want to know what K equals, or sometimes we could call that R now because we're talking about a rate. Rate R. Alright, so I'm going to start right here. I got to go in order on one, the same order as I do in the second. So 1 inch, now I'm going to go clockwise so I'm not missing. And I'm going to do 0.75. I do not like decimals. I can make it a fraction. 7/8 and 1 inch. Okay, so there are the 4 dimensions they gave us in the original. Again, we're going to start at the same location. Right hand side, this one is 2, then 1.5. I do not want 1.5. I want 3 halves. 1 3/4. New denominator times number in front, 4 times 1, plus the numerator is 7/4. Make it improper, and then finally 2. Please note that the first one and the second one are equal, 1, 2, 1, 2, so you don't have to calculate both of those. And we're trying to find K. And to see that K is the same for every single rate, or every single scale up or down, whatever direction we're going. Obviously, the right side is bigger than the left, so it's going to be scaled up. So my K should be greater than 1. Alright, so K equals Y divided by X. Y in this case is 2, X is 1. 2 divided by 1 equals 2. So there is my K. K is 2. Alright. So now I'm going to continue that and make sure they're all the same. So K equals Y over X equals 3 halves over 3/4. We have a rule in math that says we cannot divide a fraction by a fraction. So what I do is I take the numerator and leave that one, change my division symbol to multiplication, and flip, or take the reciprocal of my denominator. Then my 3's cancel. 3 over 3 is 1, and 4 over 2 is 2. And as you can see, it equals my other 2. Okay, now I'm going to do this one. So it's going to be K equals Y divided by X, which equals 7/4 divided by 7/8, which equals 7/4 times the reciprocal 8 7s. 7s cancel. 8/4 equals 2. Same. And I don't have to do the last one because we've already done it. So, going back up, always read the question when you're done and see if you answered it. Jake wasn't quite sure if his stickers were proportional to his original sketch. Since K equaled 2 for all 4 sides, then we could say, yes, Jake, you have a proportional sticker. Alright, steps. Steps for checking proportionality. Step 1. So what did we just do? We record the length. Of the scale drawing on the table. On the table, in the table. 2. record the corresponding lengths. On the actual object, bear with me, the erasers takes a minute. Okay. So that was record corresponding lengths on the actual object or picture on the table. In the table. Let's go picture. Okay, so we recorded the original, recorded the scale. And then finally check for the constant proportionality. Okay, in this case. Or possibly R, depending on what you're calling it. Alright. So key ideas. The scale factor can be calculated from the ratio of any length in the scale drawing to its corresponding length in the actual picture. The scale factor corresponds to the unit rate, R, and the constant proportionality, K. Scaling by factors greater than 1 enlarges. Scaling by factors less than 1 reduces. So we're going to go between 0 and 1. We aren't going to have negative, so it's going to be between 0 and 1 to reduce the segment. Okay. So here's an example. Exercise 1, the app icon. So now we're going to try this again. So what did we do? Well, step 1 says record the lengths of the scale drawing on the table. Okay. So that's the original. So that means I have to go back and look at my original. And it was 1 3/4 7/8 1. Okay, so I'm going to put those here. 1 3/4 7/8 and 1. Okay. Step 2 says record the corresponding lengths on the actual object or picture on the table. Okay, so that's the scale. So I'm going to put the scale over here. That's this here, starting with a half. Went clockwise, so we're in the same order, 3/8. Then the left side, 7/16, and then the top right, 1/2. Okay. Step 3. Check for the constant of proportionality, K. So I want to know what K is. I don't know what it is, so I'm going to say K equals Y over X. In this case, the first one, Y is 1/2, divided by X, which is 1. Well, 1/2 divided by 1 is. So my K should be 1/2 for all of these. Now I'm going to say K equals Y over X. I'm going to write this every time so I memorize it. Y is 3/8 right here, divided by 3/4, which equals 3/8 times the reciprocal of 3/4, 4/3. 3's cancel, 4 over 8 is 1/2. Okay, one more time. K equals Y over X. Y is 7/16 divided by 7/8, which equals 7/16 times the reciprocal of 8/7. The 7's cancel. 8 divided by 16 is 1/2, and they are all 1/2 because this one we had already done. Okay, so this is a scale drawing, scaled down, a reduction, because K is 1/2 and 1/2 is less than 1. So since 1/2 is between 0 and 1. Okay, I didn't like this example, so I'm going to skip it in my video. Example 3. Your family recently had a family portrait taken. Your aunt asked you to take a picture of the portrait using your phone and send it to her. If the original portrait is 3 feet by 3 feet, so here's the original. I'm just going to draw a little picture. 3 feet by 3 feet. And the scale factor is 1/18 of a foot. I'm going to do the same thing, folks. Original scale. Reminding myself, left side's X, right side's Y, and I need to know what K is. Now I do not. K is given 1/18 of a foot. Alright, so now we know K, we don't know Y, so Y equals K times X. And the original, just bringing these over here, 3 feet, 3 feet. Y equals K, 1/18 foot. X, which is 3, which equals 3 over 18, which equals 1 over 6 feet. I don't know what 1/6 of a foot is, but multiply by 1 foot. And we get 12 over 6, which is 2 inches. I do not need to do this again. 3 feet is the same square, and then it says, draw the scale drawing that would sketch. Oops, the best size of your, that would be the best size of your phone. Sketch and notes. So now my little scale would be 2 inches by 2 inches. Okay. There is no summary on this lesson. That is the end of lesson 17. Go do your